Hi, our lesson now is about the surface area and volume of 3D solids. Let's start by the surface area of 3D solids. The surface area of 3D solids is simply the outer area of the surface of all the planes of a solid. In order to find the surface area of any 3D solids, simply I can add up the areas of each plane that a solid have. But if the solid is considered to be a regular prism, if I have a regular prism, then the total surface area is equal to the curved surface area plus the area of bases. The area of base, it always depends on the shape of the base. If it was a circle, then the area equals to pi r squared. If it was a square, then it's side by side. Or if it was a rectangle, then it's the length times the width. But the curved surface area for any prism, curved, this is a curved surface area. Is simply equal to the perimeter of the base times the height. This rule applies only for a regular prism. What's meant by a regular prism? It's a 3D solid that has two identical bases separated by a common depth. Let's see our first shape, which is the cuboid. The cuboid is considered to be a regular prism. So, the curved surface area of the cuboid, the curved area, is equal to the perimeter of the base, which is L plus W plus W plus L, which is 2 times the length plus width times the height, which is H. And the area of bases is equal to, if I consider this one to be the base and this surface to be the second base, the area of one base is simply the length times the width, and the area of two bases, I have to multiply this value by 2. So now I can get the total area is simply equal to the curved area plus the area of bases. Let's go now to our second three-dimensional shape. We have the cylinder. What we need to know about the cylinder is the radius of its base and its perpendicular height. This is the perpendicular height. The cylinder also is considered to be a regular prism because it has two bases, two identical bases with a common depth between them. This is a regular prism. So now the curved area is equal to the area of the base, the perimeter of the base, which is 2 pi r, times the height, which is h. The area of bases is equal to 2 times the area of one base, which is pi r squared. So I know now that the total area is equal to 2 pi r h plus 2 pi r squared. This is the case when I have a cylinder. Let's see the cone. The cone is not considered as, it's not a regular prism, not a regular prism. Very important about the cone, there is a measure for this slant height to be called the slant height, which is L. And since I have a 90 degrees angle between the perpendicular height, which is h, and the radius r, I can use Pythagoras theorem in order to find out L. So I know about the cone that the hypotenuse squared, which is L squared, is equal to h squared, the perpendicular height, plus the radius squared. I use Pythagoras theorem in order to find L. Many questions won't give me the value of L or H, so I need to use Pythagoras theorem in order to find its value. So now, since the cone is not a regular prism, the curved area is always given in your formula booklet of the cone is equal to pi r L. So now the total area is equal to the curved area plus area of base, since here I have only one base. This is equal to, the curved area is equal to pi r L plus the area of base, which is pi r squared. Let's see our fourth dimensional shape, which is the sphere. The only thing that I have to know about the sphere is the radius of the sphere. Definitely the sphere is not a regular prism, but in order to find the total surface area, simply I can find the total surface area of the sphere. There is no curve, there is no bases, so the surface area of the sphere is equal to pi r squared. And this formula is also given in your 4 pi r squared. And this formula is also given in your formula booklet.